structure. Now this session, I asked Rajan to join me. He runs Upekha, he's been involved with iSpirit and all that, we go a long way. The idea is, the problem we have right now is GPUs are not available, hardly anybody can build anything out, very difficult to know cost structure models. So Rajan will help explore how to do it, but we will get started with some questions, etc. before that. Okay. Is this clear? All right. So the way we'll do it is, I will ask, you drop something. Most important thing. Yeah. You cannot live without a mobile. Mobile, that is your office. Okay, so I will ask each one of them to present in a few minutes first about themselves, about their company, and why did they start the company, the personal motivation. We are a startup with this thing. And then the important thing, don't tell me like a VC what you do, but give me a use case, what happens with and without your solution, so we understand what the AI is planning to do. So go ahead.
Hi everyone, I'm Hemant. So I started out in legal research, government policies, trained as an economist at Harvard, spent a lot of time in labs sort of grappling with data that was too textual, trying to find experts to label it. GPT-2 was a watershed moment. Me and my two other housemates from Harvard co-founded Jhana. We were all working on legal research of some kind, and it was sort of a game changer to be able to work with text as a form of tractable action. In terms of what we do, we're building a series of products. The main product that's a SaaS that's about to be released is an AI paralegal. It does sort of drafting, research, review, editing, citing, from all the corpora that lawyers use, be it citations of case law, of authorities, of statutes and notifications from ministries and so on. So an example of how that looks is right now you sort of have to manually do the process of crawling through gazettes, through case law, trying to find something of support. And then through our tool, you can either strategize and build arguments, or upload a contract and sort of review it. You can sort of draft a clause or a brief, or however else. We sort of handle the full process of a case, right from onboarding a client and taking and understanding their files, all the way up to sort of going to court for matters, building intelligence to present and argue in court, and so on. We have some other products cooking, things that involve more of the internal documentation of a firm. So this is at mature corporations or firms. They've already produced hundreds of terabytes of internal briefs and memos. Most of their work is contractual, transactional. So it scarcely involves interacting with the law per se, and interacts more with their own files. So we also build specific workflows there. For example, a workflow that you all might have experienced is, given a term sheet, which is sort of a 3-4 pager with an overview of what the more contentious terms are settled as, how do we generate your SHA and SSA, which is maybe 100, 150 pages of documentation. And throughout these sort of our core technical discoveries are in compliance, which is to say, if there is a previously approved boilerplate clause, we need to reproduce that. If there's a piece of case law, we need to accurately quote and cite that. Anything that a lawyer needs to take to court, we need to tell them exactly this is the page you're going to print out, and this is the quote you're going to insert into your brief. So a lot of our work is in making...
So he will not do any hallucination. He has to be precise to the paragraph.
Perfect, yeah. So I'll pass there.
Yeah. Can I get Dilip? Dilip, can you hear us?
Yeah, loud and clear.
Yeah. Why don't you do an intro of yourself? Go ahead.
Okay. I'm not sure whether you can see me or not, but I hope you can hear me.
We can hear you, loud and clear.
All right, great. So right now in SF, basically Dilip, I'm the founder and CEO of a startup called Cogniswitch. Personally, I'm a slightly dated piece. I started my career in the early 80s. My first startup was in 85. And my first encounter with AI was in the late 80s, 89. And those days, I heard somebody talk about expert systems and rules-based mechanisms. Yeah, I first worked on that kind of AI. So that's about me. Cogniswitch basically is a data platform for enterprises to reliably run AI. That's our one-liner. Why am I here? That's why I told about what I did in the late 80s. We were trying to take knowledge manually from subject matter experts and load it into a very fancy expert system. So, like you could have all kinds of inferencing, forward chaining, backward chaining, really fancy stuff, object-oriented database systems. But I think the way we did it, we failed. And that stayed with me throughout my life. I moved on, we pivoted, kept in touch, did many things. But this was one, for me, Cogniswitch is a personal itch that I'm scratching. Basically, when I saw attention is all you need, BERT come out, GPT came out, I started getting excited.
I like the fact that you are clear cut. It's a personal itch, but great things are always built from personal effort.
I hope so. I'm hoping that's going to happen because we are seeing some very interesting responses. But basically built this because we think, so the Cogniswitch's motto is, I think it is not, we believe it is not I think, we believe it is not an AI problem, it is a data problem. If you take natural language data, which is natural language text, which is for human beings in any walk of life, and then you're trying to now take that and chunk it, embed it to what you want, and throw it at a probabilistic engine, reliability is not going to be anywhere near to that, for sure. You can do RAG, you can do XRAG, YRAG, whatever we do. We believe that first, the data needs to move from a unidimensional natural language structure to a multi-dimensional information structure, which is like more knowledge oriented, which is more richer, connected. And if you have data in that form, that's one part of it, getting it ingested, pretty much like how you store data, a web developer stores data in a database. On the other side, when you want to retrieve it, instead of SQL, you would use natural language. But we do the task of finding out, doing a deterministic retrieval of the data which you cannot hallucinate on, data which is related to your standard operating procedures, your policies, your regulations, your procedures, product documentation. These are things, I don't think there's anything to be generated. But these are very vital for a very meaningful GenAI pipeline, where you can mix and do magic. The magic is possible, the AI is available, but the core data is what matters. So that's what we are focused on.
Thank you.
Use cases, if you one use case I would like to
30-40 seconds. 30-40 seconds if you can finish.
Yeah. The use case is about, we did this for one of the largest and oldest professional bodies, the American Society of Civil Engineers. Standards body, no hallucination possible. We just finished a very deep engagement, after which we got a signed up case study where we showed how standards data can be moved to from the current form into a deep knowledge base or a knowledge structure, and that can be reliably used in a GenAI use. So that's one use case we're very proud of.
Thank you.
I can talk about it.
Thank you. We'll come back. So what he's saying is we do not use generative AI for search, but we use it to process data and structure it for a knowledge graph or whatever you are using. Thanks, Dilip. We will now move to non-human language.
Hi, I'm Trisha. I'm the co-founder and CTO of Immunito.AI. A little bit of background about myself would be that I am a programmer at heart, passion as well as profession. And I have been in the startup ecosystem after doing my master's, building products, ML-based products where classification used to be the big thing back then, to now where I am trying to now design antibodies using generative AI-based architectures. However, it is not languages that we use, and I'll come to the technical bit probably when we chat a little bit longer. Essentially, antibodies help your immune system to fight against diseases. Now, they have a very special property. They can go and bind to only a specific target and very strongly that to it. Now, we can harness this power of antibodies and we can make drugs out of them. However, in order to do that, what you have to do is you'll have to use, in a classical way, population of mice or big animals. I wouldn't use llama alpacas, but yeah, they are llama alpacas animals, not models or camels, where you would inject those animals using your pathogens, and they would generate the antibodies for you. You'll harness them, and then you'll try to convert it to a drug to be used for human beings. Now, that is one of the biggest challenges, right? So to convert that biological molecule to a drug is one of the biggest challenges which we are trying to tackle by building an AI platform where we are designing a drug to begin with. So we don't have to spend any effort into that conversion. The second most obvious thing is these pipelines take approximately 5 to 10 years, even before your clinical trial starts. So when your clinical trial starts, add 10 more years to it. So we are crunching that down to about a year, where the software part would approximately take a month, and then we have also a wet lab component. We are incubated at CCamp and CBS, which would take approximately 11 months to complete the rest of the pipeline. And then we can hand it over to pharma partners to do the rest of clinical trials. To give you a little bit of context where antibodies and how antibodies are used, during COVID times, you must have heard antibodies were extracted from healthy patients and injected to patients who were suffering from COVID. Something similar here, we are just injecting animals or AI pipelines with our pathogens and developing antibodies which can then be converted to a drug to cure diseases like cancers. It started as a scientific curiosity of me and my co-founder, and a little bit of insight into the industry that this is required. And soon it became a personal challenge for me. My mother is a cancer survivor, and antibodies can be used to treat cancer. So it is an alternate to chemotherapy. Well, one day will be an alternate to chemotherapy, where chemotherapy, in order to kill cancer, attacks all your fast-growing cells, hampers the overall health of the patient. And what I talked about, antibodies having a special property to bind to your pathogen, you can attach a drug at the tail of the antibody. It will only attack your cancer cell and keep the rest of the body healthy.
Could you give an example in the next minute? Then we.
Sure.
No. Use case example now, or you're done?
Yeah, so this is what our use case would be. I'll talk about the technology later.
Thanks. Yeah. Well, I'm running to time. Please be careful.
Good morning. My name is Abhay. I'm basically a systems engineer, and I have worked with storage and virtualization.
Louder.
I worked with storage and virtualization, and later worked on platforms like IoT, embedded systems. And while I was building these systems, the major struggle which I have personally faced as a technical founder was to sell them. And that is when we stumbled upon building a sales prospecting platform, which has all the nuts and bolts for sales teams. So typically, all the sales teams struggle with prospecting, sales intelligence, competitive insights, consumer insights, and outreach. So these are the primary issues every sales guys face. This is my personal problem because I also failed to build these while I was building other products. So we started Cloudura to solve this challenge, and we have been able to solve it to quite an extent. Now our system can prospect contacts within 3 minutes to 30 minutes, given the size of your ICP. ICP here is ideal customer profile or your total addressable market. So our platform can help any sales individual to profile their market within 30 minutes. And after 31st minute, you can start outreaching to these customers. To outreach, the platform automatically uses generative AI on our own trained model, and it starts sending the mails in their language or in their culture for the contact they are trying to reach out. The platform provides emails, phone numbers, all of them, and sales intelligence gathered through the internet. From jobs, from company press releases, we gather a lot of intelligence. So we have small models for classification to large models to generate emails.
Thank you. What we will do now, I will ask each one of them an engineering question, like your data, how many tokens, rough idea. Your model, did you build from scratch? Are you using Llama 2? You're using something else? Where is your compute infrastructure? Are you renting? Is it easy? Do you have bought? How many people FT you have? What funding you have had? So that we get a basic foundation at the state of the startup. And if time permits, the plan. And then I will hand over to Rajan to explore what's the business case? How do you know which customer pays? What do you price it? Do you do subscription? Do you do one-up? And all those things. So I will start with Kursus. Can you talk about the engineering part first?
So we are a very small team of 30 engineers, but we have a very sizable data engineering team. Data engineering, when I say, so we started, the genesis of this problem is building the data. I kind of concur with the gentleman. Data is very much of important because data derives information, information derives knowledge, knowledge derives learning, learning derives intelligence. So we built data, we played with data. Now, if I have to talk to you about the quantum of data we are playing with, we are ingesting about 1 terabyte of data every day in terms of jobs and in terms of news, in terms of PRs and all that stuff. And we are doing this for about 40 million plus companies every day. We have contact information of about 600 million plus companies. So we are playing with a lot of data here. So when we went to a drawing board, we built a huge infrastructure on how to process this data, how to build smaller engines or smaller parsers in terms of.
And where's the compute capacity?
So compute capacity, right now we are hosting on GCP. So Google Cloud is what we are using.
And are you using any existing foundation model you are
So we started with a lot of foundation models like Llama and GPT. But when we realized that things are not right in terms of the output, we kind of trained with our own data.
He did not say hallucination, huh?
No, because the output was not right, actually. So I'll give you a good example. So when we were doing training, testing, and I was trying to write a sales email as a sales head of a quality systems company to send a mail. The output was a beautiful email, and at the end of the line, it says, I do not recommend quality automation. Right?
That's quite bad.
Yeah.
And on the funding, we just had an announcement yesterday.
So funding, we about $2 million plus funding we received from Bharat Innovation Fund. So compute-wise, we use a lot of A100s for training. Training and pre-training, and once we get the model, then
any idea what's the size of your model? How many gigabytes of parameters?
So we have very small models, like 102 million models token, and then 15 billion.
Perfect, thanks. Dilip, can I ask you about data models, your approach to life?
Yeah, so we have, like I said, we have a different, so we think it has to, we see a lot of, lot of interactions happening with respect to graph RAG, with respect to vector databases, with respect to graph. Now graph guys, the graph database guys are on the stage, they're saying that's better. So we have taken an inclusive approach. We use embeddings, we use vectors for sure. Our basic information structure is a graph, knowledge graph kind of structure. But we keep the embeddings very close to the heart of the graph. And we also use the good old symbolic, which is rules-based, logic-based mechanisms. I didn't let it go. That each let me carry it all this while. So we have a decision engine. We have a graph-based information structure. For us, it's an information structure. You could persist it anywhere. We have a layer that helps you. If somebody tells me for whatever reason, I don't know why, that I need to keep it in Neo4j or Tiger Graph, I can do that. If somebody tells me, I think Quadrant is really great as a vector database, somebody says that's where we want to persist the vectors, we can do that as well. Or we could keep it together. The persistence could be even in Lucene or Elasticsearch. And I'm sure some of you would agree, if you want performance, you obviously need to look at these things as well. So for us, the data, if you want an enterprise kind of thing, our entire infrastructure set sits inside Azure. Even for us, the model that we use is OpenAI's models, especially the one that we find even today really doing a good job is 3.5.
like
Turbo, various snapshots. And also, we use it for a different purpose. We use the LLM as an important tool in our tool set to mine the natural language source so that we can extract the necessary information and create that information structure. That
so,
model
so,
structure.
so using the
That's the
LLM,
use.
so you're using the LLM for the detection of nouns, verbs, the names, named entity recognition, so that you can then build in relationships.
Named entities, other entities, relationships, attributes for each of these.
And if I may provoke you, for example, Google went heavy on building a knowledge base, knowledge model, and a lot of the search starts on the right knowledge model, Wikipedia, there's that options. So by using a knowledge graph, you are reducing the need for going into various things, but you have a very structured way to descend the path.
Correct. So first of all, what we are trying to do is to create that picture, the model of the world inside an organization, enterprise, bodies of knowledge, whatever. That's very important. Concepts, because we have those concepts in our head, and when we read a text, we generally understand. Okay. But take an LLM, which is a probabilistic engine, and if you throw just text, which is unidimensional, it is. I mean, don't blame the AI for it. It is going to, and it's a probabilistic engine.
Yeah, thanks.
So
Dilip.
we think,
thanks, Dilip.
we think that transformation is important.
Yeah, we will come back to that later.
Sure.
In many ways, we are a data company, a search engine company. We're replacing sort of court reporters, sitting in godowns in Noida, typesetting judgments collected directly from the judge. So our data set is immense. We have a proprietary data set in the order of magnitude of 10 trillion tokens. We have a collection of models that do the work. So similar to what Dilip is saying, but very small models, in the millions and hundreds of millions of parameters, doing various tasks all the way from, extractive summarization to things like classification, named entity recognition. So we're talking encoders, dual encoders, BERT-like models, and so on. And we keep it small so that, we're not sort of hammering a nail with a machine gun sort of thing. And we do use the large foundational models, but the way our workflow works is that we have agentic pipelines where small models do sequences of tasks that put together information and collect citations and quotations. So all the research and initial drafting is done by small models, and then we use big models for the best qualities they have, which is alignment, so following instructions, and writing style and quality, which means sort of redrafting what is produced by an expert model into something that is much more well-phrased and well-structured and formatted.
So basically, he gets a very authentic, authoritative, confident ChatGPT style from Wikipedia.
Right. And we sort of have 15 million court and sort of ministry and acts documents. So these are all structured documents. So we do a lot of work in parsers as well.
Thanks. Staff, how many? What's your staff strength?
We have just 12 people, half of them lawyers, half of them engineering.
That's very small. Funding?
Just around 2 million, mostly from one investor and then a series of small engines.
By the way, most of them are looking for people first, talent, money later.
So I think data seems to be an overarching theme here, and same for us. Not because we have a lot of data, we don't have trillions of billions of data, because we don't work with text. A parallel for us might be sequences of proteins and antibodies. However, what we've seen in the 3 years that we've spent solving the problem statement is that sequences are not the right data to go after to design the antibodies. Instead, what we go after are structures, right? So we look at structures of each and every atoms in 3D space when they are interacting with their counterpart. And that is what we take. Now, that is very, very limited. These complexes are in the range of 30,000, roughly, oddly 30,000 data sets. Here, we don't have the luxury of a lot of data, so we have to do a very crucial transformation on this data. So this transformation kind of is a mathematical representation into a graph-based architecture, where now instead of two proteins interacting in space, we have two graphs interacting in space. It has all the 3D coordinate information and all the biological properties to it. And then we have different types of models which kind of try to extract a diffusion-based model, which tries to learn why these two graphs are complementary, thereby generating new graphs when a graph is given as an input. Some deterministic-based models, some even GPS-based model, EGNN-based models, which all aim to do this whole single thing, learn the structure and try to predict the structure, and then try to predict the sequence. And size-wise, we are pretty small. I mean, the biggest model for us has 1 million parameters, and there are lakhs of parameters as well, smaller models. And we are on cloud. We've used AWS in the past. We use GCP right now, and we'll continue using GPUs. Mostly, we use L4 and sometimes T4s. And for the bigger, like main trainings, we use A100s. That is what is sufficient for us. Team size for us, at this point of time, there are 8 folks on the computer science side, comprising of ML engineers and software engineers. And on the biological side, we have PhDs, again, 6 PhDs over there, and the rest are research associates. And that's what our team looks like. Funding-wise, we've raised $1.5 million kind of a round, where it was led by Pi Ventures, and we've also raised from government grants like METI, Karnataka, KTech, etc. Yeah, Elevate.
Thanks. And your journey is a marathon journey, so it needs a lot of effort. Thanks. Thanks for all of you for helping me manage time. We are almost halfway through. All of you have got some context, and you would have noticed that a lot of them are not following for hallucination problem. They are solving it in some other ways. But I will pass to Rajan to explore the business model, the financing, etc. And I think we should have enough time to take a few questions. Rajan.
So I want to start with like asking a question to the audience. How many of you are founders in the audience? Show of hands. About maybe 10, 15 of them. How many of you are trying to be founders? Okay, I mean, most are founders here, so 10, 15. How many of you are like, students or looking to sort of join, or maybe not student? How many are students? Okay, like a lot of you are students. Oh, a lot of you are students. Another 15, 20 of you are students. How many of you are looking to join a company in the GenAI space or join a GenAI project? Okay, few of you. So it looks like, the audience is a lot of you are founders, and a lot of you are like, students who are trying to figure out what is going on. So Arvind already said the context when he did his introductory opening, where he said, like, this is a very exciting time in 2023, 2024. Some of you are experienced folks in the industry. Some of you are just starting. So 20 years ago in 2003, 2002, or even in 2009, what had happened was, like, there were platform shifts that were happening, just like how GenAI is happening right now. And when that happens, what happens is that there is a great possibility for you to join iconic generational companies. So in 1999 to 2003 is where you will see Facebook, LinkedIn, Google all got started because of internet. 2009 is the time when Snapchat, Uber, not even TikTok, Instagram and all got started. TikTok was a little later. And then right now in GenAI time, this GenAI shift is creating that opportunity for another such wave of companies to come in. So in this session, what we are trying to explore is, anybody heard of the name called Harvey? Harvey, okay, Harvey, you have heard. Nobody, you have heard Harvey. So, okay, so the Harvey example. So, I was going to come to that. But anybody has seen this show in Netflix, which has a courtroom drama in it? What is the name? No, the Hindi one. Mamla Legal Hai. So you see that there are two interns there. One is called law, another is called order. Right? So what Hemant is trying to do is trying to actually replace that law and order with his own startup company. Right? And if that law, they are annoying. Right? So if they can be replaced by an AI, right? So then the amount of business that you can do That is a huge generational possibility. In the Silicon Valley, a company which has been funded for at least $100 million by all top investors is a company called Harvey. And what Hemant is trying to do is trying to do that for India. And he's taken this, he's challenged the conventional wisdom saying that, look, that Harvey can be built in India. Anybody's heard of Biocon? Everybody's heard of Biocon, right? So if Kiran Mazumdar Shah was to build a biology-related company, when she built that company, it involved wet labs, which is like, trying the drugs out in a wet lab. But today, if you were to build a company, she'll exactly do what Trisha is doing. It's just you don't have to use wet lab. You can actually find all the drug discovery by giving that question to an AI. And that AI, to Arvind's point, can hallucinate, but she's trying to make sure that she's using a diffusion-based model to ensure it doesn't hallucinate and a real drug can be produced, and can she actually build a business like how Biocon was built. Anybody's heard of Salesforce? Everybody's heard of Salesforce? So what he's doing is saying that, look, if Mark Benioff was to build a sales CRM company today, he will exactly use what he's using as an approach. And if you actually read Mark's Twitter, Mark doesn't tweet often, but now he's going on Twitter and trying to recruit all machine learning engineers he can. Badly, right? So
Thing happened, he was offering on the fly.
all the people he was offering on, and there are many people who even refused on Twitter itself saying, no thanks. Right? So because it is old age right now. But this is what he's trying to do. If Salesforce CRM was built, then they will use the exact approach that you are using. So those that are looking for jobs, like, based on some of the answers that you hear from them, you can make a judgment of, are you joining the future Salesforce, future Biocon, or future, Harvey, that will replace the Law and Order. And Dilip is remote, so, not that I have forgotten Dilip. What Dilip is trying to make sure that is that he's building this underlying Oracle-style database, which he calls as the graph-led database, to make sure all these applications run really, really well. So if you want to know that in future Oracle, Salesforce, future Biocon, and future Harvey, that is what they are trying to attempt to build. So with that, what I want to actually start with is from an approach perspective, when somebody is actually building a GenAI application, right? There are a lot of folks who are like founders here. Now there is this hype in media saying, okay, look, there is GenAI that is happening, there is a new starting point that is happening, and everybody is jumping to actually build an LLM, and that's what Arvind said, we'll continue the discussion for the rest of the day, that we will jump an LLM. The best way to think about LLM is it's like an operating system, like Windows, or like Symbian, or like iOS, and things like, or Android, and things like that, right? But when you built your sales, when you started in 2016, you did not jump into an LLM, but you eventually landed into an LLM. Can you actually talk through that and why that was important to do that way?
So when we started in 2016, what we did is basically we knew one thing that in sales particularly, data is very important. And so what we did is we, as I said earlier, that going back to drawing board and collecting the parameters, building the classification engines. So a lot of ML goes in the back end, because if you see 30 engineers cannot classify 600 million data points or contacts. So a lot of ML goes in the back end. But as soon as these models started coming in and the demand from the customers is like how to get textual intelligence or textual prospecting, can I get the profile? Can I get customer competitiveness or competition insights? That is when we landed in building these models. And then we started playing around with BERT, GPT-2, and Llama.
Yeah, so I think the founders will get it if I were to translate it for the students here. Yeah, is it audible now? So what you're saying is you started out not with LLMs in 2016, you were hand creating all this data.
Yeah.
So one of the most important thing that no matter whether you are building LLMs or whether you are building application, you have to do the dirty work of building the data.
Exactly.
And you did what? You created 600 million contacts.
So
and you now ingest.
So we created about 500 columns of parameters in terms of how a company looks, right? So these are the dimensions a company looks like in terms
And
of
what is the
size.
total data set you have?
So total data set we have is about 11 TB in terms of size.
Yeah, in terms of records in millions?
In terms of records, 600 million records.
600 million records, right? So the first point is for anybody who is building GenAI application, it may look like, the GenAI magic happened today, last year, this week, but you have to actually invest in that. Yeah. You have to actually start with that. And what you also said was that you tried out BERT, you tried out GPT-2, and that did not work for you.
For generative part, it did not work for us.
So the second thing to take away is that, you can create all of this data. You just don't go and build your own model. You go and use models that are available. When they are not working for your use case, what did you do?
Then we started training our own models, building our own models, and trained these systems for having a better responses.
Right. So I actually run a pre-stage investment fund, which is an accelerator, and I work with about 160 companies. We've invested in 120 companies. 45 of them are for AI. So the first thing that we tell, this is a lesson from what you have done, is that before product market fit, no GPU. Right? You use existing models. You first go and try that, and then see for your use case, is it creating efficacy or not? If it is not creating efficacy, then you do fine-tuning. If fine-tuning is also not working, then you go ahead and do your language model building. But like on this, I want to actually go to Trisha, but that was not your experience, and you already alluded to that you had to go to diffusion. Can you actually talk about just the problem statement and then say how did it lead to your language model choice?
Right, so we, like I said, didn't use language models. In fact, when we started...
model, sorry, I should have said foundation model.
Right, so when we started, we did look at sequence-based data. However, for us, I think the problem is that not a lot of computer scientists usually are interested in biology-based problems. Thanks to AlphaFold, people have started shifting their interest. A lot of good engineers are coming in, PhDs, researchers are coming in, but that wasn't the case maybe 5-10 years back, right? So which is why there isn't a lot of already made tested production ready.
So you didn't have
models.
a GPT. GPT
right,
did not make sense for you,
correct.
And GPT was not available for you.
Right. So I used a GAN-based architecture back then to use sequences, and then through experiments we figured out, lab experiments I mean, that it's not learning what it should have learned. It's not capturing the complementarity, why a protein should go and bind to my antibody. That is when we started exploring what is it that we were missing, and that key was structure.
So if I may interrupt, so in your case, what you have to do is you have to go and find 500 columns for each contact so that you can figure out how to actually do sales for them. How do you find intelligence to do sales? But in your case, that columns cannot be created because you need to create 3D reconstruction of the protein.
It cannot
and
be
therefore
a
model that processes just sequence and languages is not sufficient for you.
Absolutely.
Therefore, which model did you pick?
Absolutely. So which is why our core architecture has to be a graph-based architecture, because our data right now, again, because of the transformation we've done, is two graphs interacting with each other, like I said. So for that, the base needs to be a graph-based architecture, can be EGNN, equivariant graph neural networks, or can be, let's say, graph GPS-based. We do use graph GPS where you're trying to use the advantages of, let's say, a transformer-based architecture, but also taking care of the graph data that you are using, and diffusion. So one of our core generative model uses a diffusion-based architecture. However, the skeleton of it is still EGNN, because we still need to look at equivariant graphs. So we'll use a mathematical concept of diffusion, but
So what I'm going to say is that I used to explain generative AI to traditional AI the following way. I used to say that the Tesla car is not same as the combustible car, right? Petrol-based car. From the outside, it may look the same. Maybe the Tesla car looks a little better, right? But the internals are electric, right? Internals are not petrol-based combustible engine. So the most important thing is to go from point A to point B. So you're still designing cars, but are you saying if I bring in a generative AI technology, if I replace it with like electric-based vehicle, then can I have a better impact on the society, environment? Can I do this in a much better, effective way? And can it actually help impact a lot more people? Is the difference between traditional AI and generative AI? But that generative AI has been made possible by this architecture innovation that she talked about called as transformer. But what she is also saying is look, the Tesla car and the model doesn't work when you're solving the biology problem, when you're solving the protein problem. So you have to actually use something called as graph neural networks and diffusion-based neural networks. With this, I will go to Dilip. Dilip, you have been talking about graph-based RAGs, graph-based architecture for decades. Finally, in the valley, people are saying, look, there is RAG and graph RAG. Maybe let me take 30 seconds to explain what RAG and graph-based RAG is, because that's the most hottest topic today. When you use a generative application, when you actually query ChatGPT, it has been trained in the language of the entire web. But when you ask a question which is very pertinent to, let's say, one enterprise, it will actually give a very poor answer. So there is a approach that people use where they take the data of the entire enterprise and give that as a what is called as a context, which is like more like provide that as a background to the neural net, to the ChatGPT, and then they ask the question. So this process of taking the data of the enterprise, giving that as a window or a background to ChatGPT, and then questioning, that is called as RAG. Now that also has a problem, which is what Dilip has been trying to actually explain. So for that, a graph-based approach is used. So even in enterprise, a graph is required. When you're solving a biological problem, you need a graph, which is different from the electric vehicle type of analogy. But Dilip, why do you think today everyone is talking about graph, whether it is for a biological problem or even for an enterprise retrieval thing? And what can you actually try to explain it in a layman language on difference between graph-based approach and the non-graph-based approach, and why everybody in Silicon Valley is adopting it today?
I really loved what Trisha is saying. Good to hear somebody talk graph. And so, yeah, so I think it is about the model and the concepts that you need. So you talked about RAG, Rajan. What RAG, I mean, RAG came into existence because you had LLM context size limitations. And therefore, I mean, yes, RAG is taking data from outside, but you still chunked it. It got vectorized, it went into vector databases. And then you're trying to pull out maybe 200, 300 word chunks embedded in an index created. And now you have 4 or 5 words, which is a request that's coming in. And you're trying to match it using different algorithms. So that I think what is missing with an LLM is that view of the world. It's been trained on data, which is out there, like you rightly said, and it's not seen the enterprise data. But even when it is trained on data out there, I think what it recognizes, it has great capability to understand the patterns and nuances of natural language usage by humanity. But what it does not necessarily understand is, for example, if we take an enterprise, how does the enterprise world look with respect to that world itself? The concepts, the entities that interact there, the relationships between them, the attributes, the properties of those things. That model can be a very guiding effect, like putting a blinker on a horse and making it focus. So I think that's what a graph brings in. It doesn't mean that you don't need an LLM. So you need the battery, you need the Tesla. There is something else that is required too, which is basically now I think a lot of people are going back to hybrid. I think, so for us, it's a hybrid. We brought together the embedding, the vector mechanism, the graph structure, and decision engine, which is basically rules and logic, which is part of those good old expert systems that we used to work with. So a combination of this gives the LLM the necessary structure and necessary discipline to go and do its magic.
So if I were to reframe what you said, right? If you just use the transformer, or if you just use a language-based model, it is like a parrot. If you actually give it the graph-based layer, it is more like a child who can understand the concepts, right? And then when you actually make questions from a concept as opposed to just doing pattern matching, then you can actually make less mistakes, right? And that is why graph is important. And when you apply it for biological problem, it is very, very critical. But in case of certain enterprise application also, it is very important. I'm going to go to Hemant, and then I'm going to ask him that Hemant has decided to challenge from a business perspective one recent known, investor wisdom, which says that, making money from investing in software in India is a little hard. But Hemant, you are challenging that. And what are you, like, what led to sort of focusing on the India market, and what has been your experience of what is working, what is not working when you actually bring this idea to, let's say, the Indian market of legal professionals?
Yeah, the India choice is sort of twofold, right? The first is, like I think Dilip was alluding to, things like, RAG, graphs, all of these are disemergent properties of LLMs. Even training your own models, at some point, the foundational model has your proprietary data set, and it is better aligned at reproducing that intelligence. So I think the only thing that's perhaps moty in AI is having data sets that are otherwise unexposed, that are hard to replicate. And this often occupies either data sets that are within an enterprise sort of confidential or inventive in some way, or of the manner of expert opinion that's collected from, the kinds of things that lawyers give as advisory, for example. And these are things that nobody has access to besides except lawyers. So the sort of benefit of being in India then is we see the first couple of years as a time when we're trying to build data as much as we're trying to build revenue. And India has multiple orders of magnitude larger volumes of law. We're by far the biggest legal system. There are more cases here by 100x than in the US. Of course, the US legal market is, on the contra, 100x the size of India's, but that's sort of the choice we're making, is to subsidize revenue with data in the future. And we do want to sort of become more and more of a foundational sort of legal AI company where, maybe further down the line, it's not a product that we're selling, but an API, for example. And I think that's sort of downstream of having that interaction data that's sort of automatically labeling and tagging expert opinions by observing how they use a platform. The other thing is also that, there's so much white space in India, contrary to in the West, where there's a lot of hesitation to work with startups. There's a lot of multi-year deals that are already in space, and it's a tedious sales cycle. To answer the second half of the question, the challenges of working in India, I think, are not particularly special, but sort of more broadly the challenges of legal tech, and that is in a less mature setting, which can be sort of a double-edged sword in that on the one hand, there aren't those prior deals that you have to outcompete. There's a lot of white space, and you're kind of leapfrogging the technology, so there's an easier entrance point. But on the other hand, there's sort of, I think, two fundamental questions in legal tech. The first is, how do you grapple with hourly billing, which becomes the business model as you move up the value chain, because time-saving technologies aren't necessarily then useful. So then you have to come to this conclusion that, okay, actual hours spent versus hours built is not 1:1, and there is a profitability there in terms of saving time, and you have to build sort of other impressions of your product around fidelity and removing tail risk and downside from errors. The other thing is sort of, do you go to in-house counsels first or to law firms? And the broad trend in the Indian legal market is that every law students are moving in-house. Legal teams inside corporations are getting bigger and eating up more and more practice areas, except for example disputes. So the other thing we're sort of doing is making an in-house push and then making it to the law firm by clients asking for it, so because their teams have it.
Involves a lot of education very early in the game, right? I just want to pick one point that you said and go to Trisha and ask this. You mentioned long ago you built a lot of data, which now is like 600 million plus. You said that you're working on accessing a lot of data, and then your choice for India also is it is easy to access the data in India. And we all know that if you have to build generative, like language-based model or even diffusion-based model, data is that like fundamental ingredient. And then you of course have to improve it using algorithm, architectural approaches like knowledge graph or knowledge neural networks, etc. What did you do to actually get data, and how are you?
Transformation. So that was our key. I think we struggle with data a lot, that we don't have data. How do we go about it? And our key breakthrough moment was the transformation the mathematical transformation that we did. So right now I'm talking about graphs as if that had always existed. However, that is not the case. That was a key breakthrough for us. And that, what we, to our surprise as well, that kind of was enough for it to learn what it needed to learn. Of course, if you had a lot of data, it will shoot up to your 99% accuracies, right? That's not where we are playing. But that's fine. That's where we have the generative nature, right? We'll have multiple possibilities that we can then test out in labs.
Got it. So both of you are relying on data as that key ingredient. Dilip is relying on the architecture, and you are relying on that algorithm that led to the transformation that will help you compete with your competitor, or like, be that next breakthrough companies. With this, what I want to do is I want to open it up for questions and see if there is any question that anybody in the audience is curious about, or like, challenge them saying, okay, why are they going to become the next Biocon, Harvey and Salesforce?
Oracle as well.
Yeah. 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 You go ahead. I'll repeat the question for Dilip so that he can
Okay.
answer.
The question is, when you say generative AI, which is like expert system, is it also using the data to refine the rules of the expert system?
So Dilip, the question is the difference between expert systems and generative AI. When you talk about generative AI, the data, does it use to refine the rules in the generative AI approach?
I'm not sure whether experts are basically expert systems are supposed to actually.
I will reframe it.
Yeah.
Will the if-then rules of the expert system get refined by action that is being done by your system, GenAI, the learning? Is there an automatic updation of the if-then-else rules?
May not be automatic.
Yeah. So.
Yeah. Okay. Thanks.
Yeah. So when you say expert system, you're basically talking about some of the expertise typically a human being has within himself or herself in doing certain tasks, right? So if you have agents running very well, then they obviously need to have some of that expertise, and that expertise is in multiple ways. So when you set up, that's the reason why we said a graph gives you an information structure which is richer and multidimensional, but there are certain decisions that need to be taken with respect to what you find from the graph, for which you need a decision engine where you have your rules and your logic. And if then else what you said is logic, and there are some also rules that apply. So there are some semantic related rules, and there are rules that are very specific which could be set up in the decision engine. So what happens is...
Thanks, Dilip. We will need to close this. We can have that conversation later. Thanks a lot to all of you, and Rajan a lot for pointing out the Salesforce and the Biocon and all that, the future things. But he is very right. It is a fascinating opportunity for a transformational change that the technology is open. There are problems, and we don't know the answers, but we have to figure it out. Thanks a lot. Jayashree, is she there? Can we get...
Thank you, everyone.
Thank you. Thank you.
Request Som to come and hand over the gifts to
Dilip, we will send you virtually or when you come to Bangalore.
That's fine. Thank you. I wish I could see what is happening there.